In this lecture, this will be a lecture for Chapter 3. We're going to go ahead and cover some of the basic information of object information. This aligns heavily with what the book has. There will be a separate lecture or demo or video created to go through the clock display, which we'll talk about in a little bit, and a separate discussion talking around the assignments and things like that. Please take your time and go through this. Please feel free to review this video as many times as possible. And as always, if you have questions, please do not hesitate to reach out to me. If you think of a digital clock is really made up of 2 or 3 components depending on how you look at it. There's an hours and there's a minutes. You could also say there's a series of digits, so that there's 4 separate digits or up to 4 separate digits. For the context of this discussion, we're going to look at it as though there's 2 halves of it, an hour and a minute. As we work through this, there's abstraction and modularization. These are the primary concepts for this chapter. Abstraction is the ability to ignore details of parts to focus attention on a higher level problem. So in other words, we abstract an issue. You do it every day in your real life. When you have a really complicated problem, it's very hard to focus on all 300 things at one time. And what you typically will do is you'll focus on one of those 300 things, get that done, and then you move on to the next one. Abstraction is the same thing. Instead of dealing with all the separate details, bubble them up into a higher level problem and simplify the solution. Then modularization is when you take it, that abstraction, you divide it into well-defined parts. So like if you have a long-term paper, if it's 1,000 pages long, hopefully you don't have that this quarter, you have an introduction, you have body, and you have conclusion. The abstraction is the paper. The modularization is each of those 3 sections. If you're building a house, right, the abstraction is the house. The modularization could be each room, and then further modularization within that for the components of each room. So if we modularize a clock display, like I talked to before, there's one 4-digit display, or is it really 2 2-digit displays, or potentially is it even 4 1-digit displays? For this discussion, we're going with 2 2-digit displays. If we look at this and we abstract some, we call the class that would handle this number display 2 integer fields, the current value and the limit for that value. So in other words, there's hours, which is a limit of 23, and minutes, which is a limit of 59. The current value is incremented until it reaches its limit, and then what happens with a regular clock? It flips over and starts over again. What might that implementation look like? In this case, public class number display, we have 2 private values, value and limit, or variables. Public number display, what is that? It's the constructor, and the constructor takes an integer, or an int rather, primitive, in as its input. This.limit equal limit and value equals 0. This is a new piece that we hadn't talked about before. And what this says is I've got a variable named limit being passed into my constructor as a parameter, and I've got another variable limit which is private to the class. By using this, it says, hey, let's refer to the one that's inside this class, and then value. In this case, I could say this.value or just value. It's considered unimportant. You typically use it when there's potential ambiguity as to which variable you're intending. Okay? Very straightforward, but this is how constructors and setters are very often written, and it's a very common Java implementation. Now on to the source code. Get display value. We have a value less than 10. Quote 0 plus value. Remember from our last lecture, if you start with a string, everything becomes a string, so this will get converted. Otherwise, if it's less than 10, if it's greater than or equal to 10, we don't need to pad a 0. Increment method. The increment method is a mutator, and it's just going to go ahead and increment whatever value it is by 1. So in this case, value equals value plus 1. When value equal, notice that, very, very important when writing Java. It isn't illegal to make that a single equal sign, but it will not give you the results that you want. Open brace, value equals 0. So when I hit my limit, reset my value to 0. Next, is there a more efficient way that we could do this? In Java there is. There's something called modulo or modulus. Modulo is what most people call it. The division operator, when applied to an int, gives you just the left-hand side. Remember back in the days when you used to do like 17 divided by 5 was 3R2? This is the same concept. So the modulo operator, when used, gives you just the remainder. So in this case, 17 modulo 5 equals 2. 17 divided by 5 equals 3. You can use this to your advantage for something that does wrap around. Let's think about that a little more. What is the result of the expression 8 modulo 3? So 3 goes into 8 2 times, and what's the leftover? 2. For an integer n greater than or equal to 0, what are all the possible results of n% 5? So let's see. If I have a 0, I get a number, a 1, 2, 3, 4, but what's 5 modulo 5? 5 modulo 5 would go back to 0 again, okay? Because you can't have any value equal to this, because 5 divided by 5 is 1, remainder 0. Remember, this says give me the remainder. Can n be negative? Why not? So, knowing that, you could do value plus 1 modulo limit. So in other words, when I hit 59 for minutes as an example, it's automatically going to flip over on the next number. Okay, so 59 plus 1, etc. Alright, does that make sense? Spend some time, work through your numbers. It's very straightforward. You can even write sample code. I'll even upload a clock display for you to look at so you could run this exact same thing. Public class clock display, private number display hours, private number display minutes. So they're both classes. So this is their data type is a class. Constructors, etc. are omitted from here. So I've got one that represents hours and one that represents minutes. Classes of types. Data can be classified under many different types. Integer, Boolean, floating point. Don't want to confuse you here. First of all, it's a small I. Most people just say int instead of integer, because you'll learn later that there's a wrapper class called integer with a capital I, and it confuses people. Similarly with Boolean, by the way. In addition, every class is a unique data type: string, ticket match, number display, and so forth. Number types, therefore, can be composite and not simply value. In other words, a data type could be a number display which has 2 fields inside of it, or 20 fields, or 1,000 fields. You can make it very, very complicated. It's up to you. Here's the sample class diagram. Clock display uses number display is what it's showing you here, and it uses it twice, but you would only show one arrow. Okay? Here's an object diagram. Remember, objects show you what's created in memory, so these are instances. So there's an instance of number display and an instance of number display. In this case, they didn't give you the name. Normally they would. Alright, objects, creating objects. So in this case, I have clock display, which is a class. At this point, once it gets created, it becomes an object. When that object is in memory, the constructor, which is here, goes and creates 2 additional objects for itself, okay, of type number display, setting one to a limit of 64 and the other to a limit of 24 and 60. Objects creating objects, as we said. Hours equal new number display, we just talked about that, and the parameter is 24. The definition of this looks like this. So here's where it's checking to make sure that what's passed in is an int, and it goes from there. One thing you can try is make that 24.2 and see what happens. We already talked through this, but it's just further examples of what's being done. Now, what's the output of this one? Take your time, take a deep breath if needed, and go through it. So int A, int B, A gets assigned 32, B gets the 32 moved into it, A equals A plus 1, so now A is 1 greater, and now it prints out. What would you expect to see? B hasn't changed. Nothing. So out would come. Person A, person B, A, so in other words here, you should have got the original value 32. Person A, person B, A equals a new person, B equals A, change name, Delmar, blah, blah, blah. B get name, what happens? In this case, you're not going to get what you expected. This is because when you work with objects, these are addresses, not the values of. There's a different way if you're going to move them over, and you get a surprise. Okay? So we're going to go into this and have more description or discussion. Same object, object type, int I, primitive type. When you create them, object A, object B, they're really pointers to areas in memory where when they're primitives, not classes, they actually contain separate space in memory. Okay? That's a really hard concept, and that's something that confuses a lot of people. All right? With that, I'm going to go ahead and pause and create a second video for you because this one's getting lengthy. Hopefully you got something out of this portion of the lecture.